All right. So what we're gonna start off with, and again, this is review from last year. We're gonna talk about a relation versus a function. Okay. So a relation versus a function. Basically saying what we do in algebra 1, what we do a lot of is compare two things, right? And put them in a graph. So if we were to compare sales of ice cream as the temperature goes up, you would see that it's a line that goes straight up, right? Because as the temperature rises, the more sales there are in ice cream, right? So that could be an example of a relation, right? But what is the difference between a relation and a function? If you guys happen to remember from last year. So let's see. Well, let's just start off by saying, okay, when we're talking about a relation, it can look a bunch of different ways. So we can see it as either an ordered pair. We can see it as an ordered pair. We can see it as a table. We can see it as a graph. So yeah, we can see it as a graph, or we can see it as a map. And we'll talk about all the different ones there in a little bit. So let's say, for example, we had 2, 5, we had -2 and 3. We had 5 and -2. We have -1 and -2. Okay, so this can be an example of a relation, and again, we don't really know what we're comparing here. We just have points, which are 2 and 5, -2 and 3, 5 and -2, and -1 and -2. Now, these are examples of ordered pairs. So ordered pairs. And we'll usually see a lot of these ordered pairs. But let's say we want to put these into a table. So let's start off by saying we want to put these in a table, right? So what we would do is we take all the x values. So the x values are the first numbers here. Let's just put them, let's go ahead and put them into a table. So x and y. We're going to put 2, -2, 5, and -1. So that goes on the x values. And we can say on the y values, we're going to have our second numbers right there. So let's just make sure we match them up with the x value that they correspond to. So 2 and 5, -2 and 3, 5 and -2, and then -1 and -2. So that's how we would put them into a table. All right, so now let's say we want to put these into a map. So now let's say we want to put these into a map. So this is where we would have 2, -2, 5, and -1. So on this part, we have the x values, and on this part, we would have the y values. So 5, 3, and -2. Now, I only wrote -2 once because the value repeats twice in the y. So all I would do is now just draw arrows directly to the corresponding value. So 2 corresponds with 5, -2 corresponds with 3, and 5 corresponds with -2, as well as -1 also corresponds with -2. So I only had to write that once. And this is how we would write the relation in a map. Now, one thing that we need to start focusing on or getting used to is the idea of domain and range, okay? So whenever we're talking about, whenever you hear me mention domain, these are the x values in a relation, okay? So if we were talking about the domain of this example, we would say the numbers 2, -2, 5, and -1. That is a domain. So then the range would be all the y values of this relation. So 5, 3, and -2. So this is something that we're going to have to get used to because we're going to start finding the domain and range of different graphs, but that's for later on. Okay. Now let's move on into what a function is. Okay. So again, does anybody remember what a function would be? And again, this is from last year, in case anyone can remember this. Okay, so a function is basically just a relation, but it's a relation that makes sense, okay? So I don't know if you guys remember from last year, we were saying, let's say we're comparing age and height. We could reasonably say that as someone gets older, the taller they get. So that would be an example of a function, because that's a relation that we can say makes sense, right? But if we were comparing the same thing and saying, okay, we have age and height. Let's say this was age 12. And we got our height 4 feet, 5 feet, 6 feet. So if I were to draw a graph that looks like this, what this is telling us is that someone is age 12 and is 4 feet, 5 feet, 6 feet, all at the same time, which of course we know that's impossible, right? We can't be different heights at the same time. So this is an example of a relation, but we would say that this is not a function. Okay, so this is review again from last year. Okay. So So let's say again, as an example, I give the pairs -5 and 6, and we have -3 and 4, -1 and 2, 0 and 0, 1 and 2, 3 and 4, and 5 and 6. So we need to see if this can be a function. Now what we want to do is that we want to focus on the x values. So we want to focus on -5, -3, -1, 0, 1, 3, and 5. So all we're going to do is focus on those values. And if any of them repeat, then this cannot be a function. Okay. So in this case, they don't. So we would say that yes, we do have a function. So again, looking at all these, -5, -3, -1, 0, 1, 3, and 5, we would say that this is a function because none of the x values repeat. We don't really look at the y's. All we focus on is on the x values. And so for example, let's say we had the table x and y. So -2, 0, 3, and 3. And we have 0, -1, 2, and 3. So again, what we're going to do is focus on the x values. So we have -2, 0, and then we see 3 repeats twice. So in this situation, we would say that this is not a function. Okay. Now, finally, let's say that we have, a graph. I'm going to draw 2 of these. So with a graph, it's very easy to see. All we would have to do is use the vertical line test to see whether these are functions. Now what we're going to do is we're just going to draw a vertical line and see if at any point the vertical line touches 2 different points on the graph, then this would not be a function. So in the first one, we can draw as many lines as we want, and it's never going to touch 2 different points. So, or sorry, the same points. So the first one would be a function. But then in the second one, if you notice, all we have to do is draw 1, and we touch 2 different points there. So this would not be a function. So it's very easy to see if a graph is not a function or if it is a function just based on doing that, the vertical line test. Okay. So I did forget one example. And using the mapping. So let's say we have 2 relations. In one of them, we're going to have 2, -2, 5, and -1. And then on the other one, or 5 and 5, 3 and -2. Let's say the other one is going to have -2, 0, 3, 0, -1, 2, and 3. Okay. So I'm going to draw corresponding lines right here. And let's see, -2 goes with 0, 0 goes with -1, and then 3 has 2 values. Okay. So again, we need to recognize the difference here between a function and not a function. Okay. So in the very first one, we have 5 and -1 both pointing towards -2. Now what this tells us is that the y value is repeating, but that doesn't mean that the x values are repeating. We have two different x values, 5 and -1. So we would say that yes, this is a function. But that's different from the second one where we have number 3, the x value going to two different y values. So that means that 3 and 2 and 3 and 3 would be put together. That means that the number 3 is going to repeat. Therefore, we do not have a function right there. Okay.